I'll give you $1.
Good news, we get to record today. Yeah, doesn't really affect you guys. I couldn't record AP this whole week. It was really strange. So we can now. All right, if you don't have a calculator, go ahead and grab one. We're going to do a really quick little lesson, and then you can go back to playing or working on whatever you need to do. Yes, there's a module and a skills test.
I'll do that.
Yeah, do whatever you want. You got a 3-day weekend. You can do it on President's Day.
That's what I'm saying. Wait, how much do these cost? So I want to complete my set. I look, you want a tractor?
Where'd you get these?
I'm sorry. Everything comes from Amazon.
Oh, that is sick. Well, lucky I'll get you to race.
Okay, 30 more seconds, then we work.
Yeah, watch this. I give you drive-by script so fast.
Okay. Ladies and gentlemen, we can do stoichiometry with moles. We did that first. Then we did stoichiometry with grams. We did that next. And today we're going to do stoichiometry with liters of gases. So sometimes you have things that produce gases, and sometimes you have gases that produce things. So it's really simple. All you need to do is tack on a gas density block to either end of your T-chart. Gas density is always so many grams per 1 liter. Kind of like the molar mass is always so many grams per 1 mole. Gas density is always so many grams per 1 liter. For instance, oxygen is 1.43 grams per liter. So if you are starting with a volume, the first thing you're going to do with that volume is get it to grams. And then you're going to go liters, grams, moles, mole ratio, grams. Maybe you're done there. Maybe you have to go back to liters. We'll see. If you end with liters, you're going to do your grams to mole ratio to grams to liters. So the gas density is usually on either end of the T-chart. Any questions so far? All right, let's do one together. One in your own. Oxygen's gas density is not one. This is not the one I want to do. This is just to get you warmed up. So oxygen's gas density is 1.43 grams per liter. What is the mass of 5.96 liters? So you go 5.96 liters. Liters has to go down here to cancel out, and it's 1.43 grams of oxygen. Liters of oxygen. Okay. So again, just like before, liters are going to have to cancel out, and you're going to convert liters to grams. Sometimes you're going to convert grams to liters. In this example, this is actual T-chart, actual full stoichiometry. Here we go. What volume in liters? This is not a T-chart. I need to fix this. Anyway, we can still do it. What volume in liters of CO2 is equal to 3.15 moles of CO2? The gas density of CO2 is 2 grams per liter. So in this case, we are starting with 3.15. I know, we don't change it.
Thank you, Branch.
What's the next verse?
Okay.
Moles of CO2. This is not a full stoichiometry. I apologize. Last one will be. And again, nothing goes here. We're going to move down our moles of CO2. Because we're going to need to convert our CO2. Now, some people will tell you that there is a conversion from moles right to liters.
No, wrong.
Those people will be right in about 2-3 weeks. Basically after spring break. Then those people will be right. But you need a lot more information. So there will be a way to convert between moles and liters later on. We're going to learn that when we do gas laws.
Oh, wait, there is a way?
Yeah, it's right there.
It's not now.
It's just Just later we'll use those formulas to do that. But right now, we're going to convert our moles of CO2 to our grams of CO2. And where do I get a mole-gram conversion? Periodic table. And the periodic table tells me, for every 1 mole, I got a 12 for carbon, and I got a 16 and a 16. So for every 1 mole of carbon dioxide, it's going to be 44.0 grams. Good old gram to mole. How are we doing so far? Wait, no? All right. So we're looking for liters. It says what volume. So we're going to move down our grams of CO2. And this is where we're going to convert our grams of CO2 to liters of CO2 using the gas density. Then that 1 liter of CO2 has a mass of 2.00 grams. So go ahead and bang those out, and let's find out what the volume would be of 3 moles of CO2.
Well, I beat your crossword.
You completed this crossword. Feels like 60 or 70. What is it? 69.3 liters of CO2. Does your work look like my work?
Yes.
No, it doesn't. What can I help you with? How does your work differ than mine? We're good? Okay. Do you have any questions about this process? Again, gas density is just one more conversion we tack on to either end of the T-chart. If you're ready to do one on your own, give me a thumbs up. Moving right along. This one's for you. Oh, it's a big one too. This takes into everything we've learned so far. If 11 grams of hydrogen and 98.2 grams of oxygen react, what volume of water vapor, water gas, will be produced? The density of water vapor is 0.800 grams per liter. So go ahead and take some time, bang this through. Big hint, you have two starting amounts. What do you have to do? 2 T-charts. Good. Two T-charts. Lila sets cars over at 3D printing, so we're going to run
Wait, is that you
Tuesday.
Dude, what's your bill?
I think we need one of everything. Mine has an armor who works every day and stores.
He's really not happy about using his farm subsidies.
Wait,
Oh,
he was
you
really
make
mad.
CO2.
He was like, I voted for you, you took away farm subsidies.
What do you mean make CO2?
one.
Make carbon dioxide
Of
of the plane. Second part of the plane.
What are you trying to say?
I can make the first part, so you make the second part, we make the plane.
You should read that.
Let's think about the custom code.
Oh, I already did mine.
No, I'm not too because I'm sure.
Just have the custom code on like
No, I need.
the end.
Oh, mine's finished and yours isn't. I have the end.
It's a 6 in 1 set.
Like him in
So we need all 9 pieces.
Wait,
We need one of every set.
look what?
I don't think that's how you make the plane.
Is it this one?
Yeah.
Yeah, we need this.
No, we need at least 9 pieces.
I'm.
Oh, no, yeah.
Wait, is this 6 on this? Is that why it's like
No, it's supposed to be like a question.
So police car, race car.
this squatter? Because the rewrite the ball when you get a flag.
Yeah.
It makes it have a good cool stance to it.
Oh, yeah, we only need 6.
Yeah, perfect.
Wait, should we buy them?
You still, do you like my custom gunner car?
I'll keep on class. I
All out.
It needs to be a good
I don't- I
car.
have like
Exhaust off the
Don't worry,
back.
my job started.
Everyone takes $1. Yeah, you hire it.
The original gun.
Where's the steps to yours?
Wait, who has a picture of it?
Brandon, will you be doing any chemistry today?
Maybe. I want to vote.
I get it, but we do have work to do too. It is a school after all.
Okay.
Oh, shoot. Yes. 0 through 4, or 4 through 6.
They're numbered? I didn't know they were numbered.
Yeah, if we get all of them, we make a plane and a boat. We
Yeah.
just have to combine.
Cool. Well, I have
That's gonna take,
right here.
that's gonna take a lot of cooperation.
No. I'll give anyone 25 cents for
Or fight.
Custom gunner car. I really do be like, yeah, I made like the coolest fucking. So I like this cool. You know, like the like box. I like this cool gladiator arena. That was so
No, these
bad.
are probably like 25.
Right? It wasn't like something crazy. It was funny. Small pieces. I literally did a war wagon tow truck from Mad Max. Like from only those pieces. It actually
I
looks
might have
like
to start
pretty
mine
cool.
later.
And it's still together and everything.
Yeah, one by
It's like a fully operated tow.
No, I want to buy. You know, like the cars.
Yeah, I have.
Cars are like one of the $8.
Dude, first like bring it. Should I bring home? Let's say, tell me on this.
Yeah.
Does the beginning of your T-shirts look like my T-shirts?
I did 2.0.
I did 2 dozen.
2002, sorry, yeah, 2002. There we go, thank you, better?
Bro.
What the?
I think it's hard.
Uncolored, bro.
Well, just like every limiting reactant exercise, it's gonna be whatever makes the least product. But in this case, the product is gonna be water vapor volume. So liters of water vapor.
You were ready for me to go.
Just like no, it's 6.7. Oh, one problem.
The gunner truck.
You're getting hurt.
The problem with it, it's the same parts.
Hey,
The problem with that is you squat it. So it's the same.
It doesn't start that way though.
This is what you did, Jackson.
No, look, the windshield's facing this way. It goes down.
Oh.
No.
Then why is it facing that way?
That's, no, it's either from forward to be done or downwards. So it goes backwards, like, but when I'm going towards like
Actually doesn't.
No, it was
stuff like that, it works like that. You know? So it's like the reverse of squat, it's actually cool. Honestly, he's not really good at training.
Okay, take a look. Does your work look like my work?
Yep.
And if it did,
It kind of does.
if hydrogen is our limiting reactant, how much water vapor would we make? If hydrogen was our limiting reactant, how much would we make? Still doing math?
Yeah.
Okay, finish your math.
Let me plug in my calculator.
Press some buttons on the computer.
Oh.
What's 32 times 0.8?
You were ready for this.
32?
Yeah, times a quick.
I can. That's a big number.
You can just divide by parentheses 32 times 0.0.
25.6 is what you're looking for, Branch.
Thank you. So I got approximately 15.4687
For the hydrogen one?
for the top.
Can I get a confirmation that it's 15.4?
15.5.
15.5? I'm not getting any confirmation on that. Let's wait.
Yeah, I'm not doing a good job then.
Stop that.
Y'all gotta make an improvement.
I like this thing a lot more too.
What'd you get, Frank?
Mr. Byers,
Yes.
my hot rod.
Yes, I do.
What'd you get?
122.
Yeah, I got 126.
122 for hydrogen.
I mean, actually, look.
So most people got 123 or 122?
122 less.
123 liters of H2O?
What did I do wrong?
What was it?
What's 11 times 2 times 18?
Just let your calculator do it. 11 times 2 times 18 divided by open parentheses, 2 by 2 by 0.8 close parentheses.
Then divided by.
Oh, it's because I did the top one divided by the bottom one.
It is. All the top divided by all the bottom.
I did like the top one, it makes 2 divided by the bottom one. And that's why I
So if hydrogen is our limiting reactant, we would make 123 liters of water vapor. How much would we make if oxygen was our limiting reactant?
Yeah, I never did on this.
Would you choose? 138.
You can't just say what Shane said.
It's 138.
Actually, mine is true.
How about someone on this side of the room? How much water vapor are we gonna make? 138? Okay, I'll take it. All right, so which one is our limiting reactant?
H2.
H2. So here's our limiting reactant and the product, 123 liters of H2O. So if you ever have a question or if you ever have an exercise that is asking you for liters or providing you with liters, you're going to use your gas density. If your first given number is liters, it's going to given, then liters to grams. Liters to grams. And if you are ending with liters, you're going to go gram to liters. All right, questions? You guys ready to work on your own?
Yes.
All right. I will press the button.
Bye.
Press the button. Bye-bye, absentee.